Good morning everyone. This is Preeti Verma from Computer Application Department. Today we are going to discuss about data structures, that is a stack. Before going to stack, I want to explain about data structure. What is data structure? Data structure is the one kind of storage technique where we can store the data and how we can retrieve the data. So, there are two types of data structures, that is linear data structure and non-linear data structure. Stack will come into the linear data structure. So what is linear data structure? In linear data structure, data is arranged in linear sequence. Means we will be giving a continuous memory for the element, for storage of the elements. And if we want to retrieve the data or if we want to traverse the data, we can get that item in a single run. So, stack is the example of the linear data structure. Stack is also called as last in first out collection. Why it is called last in first out is we will be having one continuous memory. There we will insert the data in one end only and we can get the data from that end only. So whatever will be inserted last in the data, you can get that data at the first. So this is the property of the stack. We will be having one continuous memory and from one end only we can insert the data or delete the data. So here there is an example of, you can see a stack of books or plates. In that the plates are which plate has come first, it has to wait longer to get out from that or to take off from that pile of stack of plates. Okay, so there are some operations which we can perform on the stack, that is called push and pop operation. Push is for inserting the data into the stack and pop is for deleting the data from the stack. So previously we have discussed that we can do this push and pop operation from the one end of the stack only. So push operation is to insert the data and pop is to delete the data, and there is another operation is there, top. Top will represent the element which is currently located onto the top of the stack, means recently inserted data it will be pointing. So here you can see the example that we have one stack which will be having A, B, C data, already it is there. Now we want to push D on this stack. So we will use the push operation and then we can insert the data onto the stack. Now if you will call the top, then top will return the D which you recently pushed the data onto the stack. Again we are pushing E, so again it will come onto the top of the stack. Again if we want to pop from the stack, so it will pop whatever recently inserted. So you have inserted E recently, so it is popping from the stack, similar to D. Okay. So now we'll see the algorithm for inserting the element into the stack. So here I have made one function named insertion. It will be having the arguments A, top, item and max. A is the stack name, top is the top element of the stack, item is the what item you are going to insert onto the stack, and max is the limit of the stack or the maximum size of that stack. So to insert data into the stack, you have to check one condition, that stack should not be full. So here I am using top equal to max. If it is full, then it will show it can print that stack is overflow. If it is not full, there is space to insert the data, so just you have to do top equal to top plus 1, and into the top you have to insert the data. So in this example, before stack it is A, B, C. Now D you want to put, so what you have to do, top equals to top plus 1, then in the position of top you will insert the data. Now algorithm of deletion in stack, that is pop operation. For pop operation I have made deletion function. Its argument is A top item. A again is the stack name. Top is the top element of the stack. Item, which item we are going to remove. So here also we'll check one condition, that is stack should not be empty. So if top equal to 0, then there is no element in the stack to remove. So we'll just print that stack is under flow. If there is some elements in the stack, then you have to do in the item, the top element will go into the item and you have to do top equal to top minus 1. Algorithm to display stack items. If you want to display the stack items, so you can make one function that is called display, and its argument will be top, I and AI. Top will be again referring the first element or the top element of the stack. I to go through all the stack, and AI is the element currently into the top. Now we'll discuss little bit about application of stack. So we can use this for reversing a string. So if we have one string and if we want to reverse the string, so what you can do, you can use the stack. First insert all the letters of the string into the stack, and then after ending of that string you can start popping the letters from the stack. It will come into the reverse order. Second example is postfix expression. Postfix expression is used to write arithmetic expression. In journal we are using infix notation. In infix notation, 2 operands will be there and 1 operator will be there, which will be between 2 operands. In postfix notation, there will be 2 operand and 1 operator, but operator will be at the end. That is the postfix expression. So to solve this postfix expression, we can use the stack. So here I have taken one example, that is, you can see one string. First letter of that string is 4, 5. Then you can, whenever operator is coming, you should insert or you should push that data into the stack. So 4 you are pushing, then again 5 comes, you are pushing onto the stack, then operator has came. Whenever any operator will come, you have to pop two top element of the stack and then do the perform the operator. Then you have to push the data onto the stack or result to the stack. So here we will pop 4 and 5. We will perform the operation summation, that is plus. 5 plus 4 is 9, and again we have inserted to the stack. Again that 7 has came, so 7 you will push into the stack, 2 you will push into the stack, again minus has came, so you have to do difference of 2 top element, starting currently top element. So 2 minus 7 is 5, result you have to again push to the stack. Again multiplication has came, so 2 elements of the stack is 5 and 9, so you will multiply 5 into 9, that is 45, and again 45 will be inserted to the stack. So this will be the example of a stack where we can use to calculate the postfix expression. Thank you.